I have the pleasure to do the first keynote of the day, so the pressure is on. And I thought a lot about what I will talk about today, and I settled for a topic that is most often underrepresented when you see what AI talks are mostly about, which is on operations. So basically answering the question, how do I operate my AI agents at scale, responsibly, and how do I avoid unintended consequences, the missing 5%. So my name is Mirco. I am the Director of Applied AI at WebPros. And in my role, I'm responsible for contributing to our product teams, namely cPanel, Plesk, WHMCS, to help them on their AI initiatives. In addition to that, I'm also working quite closely with our new AI native products, Nova, for example, our AI application builder, Xovi AI, which is our tool for generative engine optimization, the successor of SEO, and also the WebPros Cloud, because AI is very power hungry, and for that you need infrastructure. So before I jump into the content of my presentation, I'd like to ask you a quick question. So give me a hand if you interacted with an AI agent in the past few months. Customer success, coding. Okay, I can see plenty of hands. If you raised your hands, I think you are in good company, because last year, Gartner made a research that 40% of enterprise AI applications will feature some sort of agentic AI by 2026. And the reason why this is impressive is because this number was down to 5% the previous year. So there was a lot of skepticism about AI agents being useful, paying off, not doing a lot of mistakes. And you can see that there is a big rise in adoption of agentic AI. At this point, I could say this is a good outcome. I could end my presentation here. But this is not really the subject that I want to talk about. I want to talk about what is the side effect of this adoption going above the roof. And I want to start off with showing you some examples from the past few years when, for example, in 2023, a customer tricked an AI agent to sell him a car for $1. So this screenshot got featured very often on X. It has 20 million views, hence I'm also talking about this. The impact was that the car dealer had to deal with that customer. They luckily couldn't agree with him that it wasn't a valid contract, but still there is a brand damage because of that. So it can also go the other way around, as an example from 2024 shows, where Air Canada was basically putting up their AI agent to help customers with things like refunds. So this AI agent basically went and hallucinated a refund policy that didn't exist. They actually went to court and they lost, because the court argued this chatbot is part of their website and it is treated similarly as any other policy there. So they had to pay the refund. But it's not only about customers tricking your systems and basically working against the AI agent, it's also about misuse. So these are very powerful systems, and last year there was a research where they tried to use coding agents to create sort of scam pages. So they call this trend vibe scamming, analog to vibe coding. So it gives you the power to create scam pages at scale, and we are pretty sure that we don't want to see that branded with our logo. So I could play devil's advocate here and say, these are just singular incidents. Why do they matter to me, right? So let me zoom out to the bigger picture. If you look at the past few years of AI incidents that has been reported to a public database, which is called the AI Incidents Database, you can see that from 2023, there's a steep curve on incidents being reported and incidents being confirmed from that database. So it's not only singular incidents. It is really a problem that you can measure, and effectively, it is something that we need to take care of. Now, the next question would be, how do we take care? So I could show you now, this is the tooling, have a look, figure it out. We thought we were very enthusiastic about deploying AI agents, and now I'm telling you we have to manage this whole ops stack, and we deploy helper functionality to deploy our agents. So we most likely end up in a complexity overload situation, and we don't want to be there. Let's all agree on that. So I want to take a step back and show you what we as WebPros did when we were deploying our AI agentic systems. And it starts with the traditional software engineering principle that you start with your requirements, right? So you look at your applications and see what is the specific requirements that your application has towards the AI. And I want to start off with Nova, so our AI application builder. So in Nova, we have 3 priorities. There are many more, but 3 priorities if it comes to the LLM interactions. So one is we need to be sure that whatever it generates is compliant. So we don't want phishing websites being created by our tooling. The second one is usage and cost tracking. We need to make sure that whenever AI agents go off, they spend tokens, and we need to make sure that we see what is going on, and we optimize for that. And the third one is also very important to Nova, because you can see the pace of models that evolve. I mean, it feels like there is a new model being announced every week. The pace is really crazy, and we need to basically invest into evaluating new models when they are basically announced by the vendors, and check whether this works with our current setup. The second application that I want to show you is Xovi AI. It's our tool for generative engine optimization, and it helps you basically measure and optimize your brand visibility in AI chatbots like ChatGPT. So what we have to manage here is a hallucination cycle or triangle, so to say. So we have rule sets, how to optimize your website. We have the website, this is the content that we want to analyze. And we have recommendations that we basically derive from the rules and the website of the customer. So we need to make sure that all these connections are relevant. So, for example, the website needs to be relevant for the rules to apply. So if I want to optimize the visibility of my product, I need the website to be referencing that product in the first place. Otherwise, I risk hallucinations to occur. The second one is the rules need to be followed by the recommendations, as well as the customer website needs to be relevant for the recommendations. So if they basically feature some paragraph of the website to be optimized, we need to make sure that this is up to date. So the third example that I want to give to you is our AI assistants. So in our AI assistants, we have basically free text input. Customers can put whatever they want. And one important aspect here is PII. So let's assume a customer wants to just set up his billing console with his new credit card, and he just pastes his credit card number. What we want to avoid is that we store and use that information somewhere in the systems that it can possibly surface through the chatbot. So we need to detect it when it arrives, and we need to clean it, and we need to make the customer aware that they shouldn't basically paste these things into a chatbot. These 3 examples, 3 applications of operative mechanisms to protect our LLMs, or LLM applications, can be basically translated into a framework. And this framework that we use has 3 pillars, and they are all interconnected. The first one is we need to understand what our AI is doing, and we need to understand in real time what it is doing, and this is why we have observability. The second one is we have guardrails that help us protect and police our applications such that things don't go wrong. These are the things that we know. And thirdly, we have the infrastructure layer, because AI needs power, as I said, and power needs the infrastructure in the first place. And you can see the arrows in between. So they are very much interconnected, and I will tell you why. Let's zoom into the observability part, the understanding piece. It's like looking into the black box. The LLM is a black box, and we need to understand how it comes from A to B. This helps us accelerate the development cycle because we understand what our users are doing, where they hit like a dead end, for example, and we can engineer features on top of that. So it's very useful for not only observing, but also informing your next decisions. Then we have the experimentation piece, and a good observability tool needs to help you collect data, collect feedback from customers, and then feed that into a data set that I can use for testing it with a new model. The third aspect is cost and usage tracking. So since observability tools are typically tracking every interactions with the LLM, it also helps you to understand what are your costs, what are your spend. The fourth thing, and this is where the connection to the guardrails will take place, is it helps you discover what you don't know yet. So where things go wrong, which you didn't anticipate, because LLMs are like have an unlimited attack vector space, and the unknown unknowns will discover once you deploy things like observability. And once you know them, you can feed them into what we call like guardrails. Guardrails work on two sides of the LLM. So you have input guardrails and you have output guardrails. They sit in front or after the LLM. The typical input guardrails are things like prompt injection detection, the PII detection as well that I've already talked about. And on the outbound side, you have things like hallucination checks, so to break the hallucination cycle that I've talked about, compliance checks, there's no scam page, and they can be categorized into three different types, and typically they are most powerful when combined. So the easiest one is the algorithmic guardrail, so things like a regular expression to check whether your input is actually valid. They are very useful if you have a limited input space, but they are very brittle as well. So if you need more flexibility, for example, credit card formats can be different for different countries or for different suppliers, you have classifiers. So classifiers are typically small machine learning models that are specifically trained to do some task. So for example, PII detection. They can run on small infrastructure. They can detect your categories, but they suffer from model drift. So for example, if formats change, they can be missing the detection. And this is where you have the third category, which is a second LLM that judges the output of your first LLM, which is typically called LLM as a judge. They are most flexible. You can instruct them what to do, but they are also having its own 5% where they fail. So this is all to do risk management in the end. And secondly, they also need a lot of power to be run on, so they are GPU heavy. And this is where they connect to the third pillar, which is infrastructure. So if we are thinking about how to power guardrails or how to power AI in general, we have three routes that we can choose. The most simplest is we just go consumption-based. We use the Geminis, we use the OpenAIs, we use the Anthropics to power our systems. And that is totally fine if you want to get started, you want to do some experimentation, you have a small user base. If you have a growing user base, you will see with consumption-based models, you will have high costs, which then basically leads you to the next two options: buying your own GPU infrastructure, which It requires you to do a lot of upfront investment. For this NVIDIA card, for example, around $10,000. It is really good if you know the volume that you need to operate. Or you have a third option that you do a lease. The same card is around $1,500 a month. You have predictable cost. You don't have that consumption-based problem here, but it is really well suited for scaling teams, and if you need that flexibility to basically operate your AI applications. And this is also the path we choose at WebPros, trying to operate our own infrastructure for powering our guardrails. Now you might ask, how do I choose between these three models? I will give you a quick example, like a cost calculation. Aside from things like reliance and resilience from cloud providers, you also have simple math that you can apply. So in this picture, you can see one guardrail, so the cost of one guardrail depending on traffic. On the x-axis, we have the requests per minute. On the y-axis, we have the estimated monthly cost. This is a guardrail that we actually applied for one of our projects, and it has around 3,000 input and 5,000 output tokens. Each line is a different model. You can see the steep curves are GPT 5.2 and Claude Sonnet, the biggest models. And you can see that at half a request per minute, they already hit the monthly 1,500 lease price. So this is one question to your chatbot every 2 minutes, which is not a lot. If you use smaller models like Haiku or GPT-5 Mini, you have more flexibility with the traffic. So the smallest one, GPT-5 Mini, comes around 3.5 requests per minute to hit the threshold. But still, this is 3 interactions with your chat application within 1 minute. If you think about a global deployment, this is going to be hitting the threshold quite quickly. So you can do that calculation for yourself. Now there's one last question that I want to answer, which is the risk equation. Why do we need to do it in the first place? So you need to consider all the things that we just saw. You have potential reputational damage. You have the scaling costs with the APIs. You have also, in addition to that, legal liabilities, especially in Europe, GDPR, the EU AI Act that is becoming active from 2027, which can cause you problems if you don't follow proper risk management here. You have security breaches that can be applied if you are not protecting your data. And on the other side, you have the investment to protect, which is, in this case, you deploy your GPU infrastructure, you deploy your guardrails on top of that, and then you deploy it, connected everything together in the observability tooling. So the question is rather, can we afford not to protect our applications? To quickly recap what we just spoke about, so 3 points that I want to highlight. The first one is, if we are thinking about operations in LLMs, we need to think about an interconnected system. So we are doing the monitoring, we are then translating that into protection mechanisms, the guardrails, and then we are optimizing our infrastructure for that. And we are repeating that with every new detected risk that we see. The second one is more of a personal opinion. So I think investing into automated evaluation is very important as well. The new models drop very consistently, and the pace is going faster. So in order to be fast to market, you need to basically be able to automate some of that evaluation with creating data sets upfront. And the third one is, the last point that I made, do the math and consider running your own infrastructure, because it will not only make you independent from the cloud providers, it will also give you better performance at scale. And with that, I have a small last call to action to everyone. If you're interested in speaking to us about AI infrastructure, there's a QR code. It will lead you to a small form. You can just answer a couple of questions, and basically we'll follow up with you on that topic, or you find us at the WebPros pavilion outside and speak to us directly. And with that, thank you very much for your attention.